as Caroline said, I'm going to talk, oh, this is too sensitive. Okay, well, I'm going to talk about early age cracking in hot mix asphalt pavements. Our branch, the flexible pavement branch, we've been working on this topic for a long time. I started working for TechStat in this branch 10 years ago, and it was when we got the new book, 2004 spec book. And all they were talking about it was the Hamburg, how good the Hamburg was, and rotting, and trying to reduce rotting on our payments. And now we get this new book, and now it seems that all the changes that we made is try to reduce cracking. So that's why I love engineering. That's why I love materials, because it's always something coming up and something to learn. So I'm going to start with common myths about cracking. And you already saw the first one, maybe the second one too. I can prevent it. Cracking is not that big of a deal. If I use recycled materials, I can have a crack-resistant mix. Don't worry, maintenance will take care of it. I think this is the one that is not a myth. Maintenance will take care of it, sometimes more than what we want to. But so let's talk about cracks. The truth is that all pavements crack. Why? Because we have moisture changes. We have Mother Nature that changes our temperatures, materials. Well, we're going to have oxidation in our binder. We're going to have aggregate breakage. And, of course, we're going to have traffic. So stresses are going to be applied in our pavements. The question is, when is it going to happen? We know it's going to happen. When it's going to happen? So these are the types of cracks. And I'm not going to talk about this. Maybe you already saw it in your pavement design classes. But we know we have different factors that causes the cracks. We can have top to bottom, bottom to top cracking. So for the next 20 minutes, I'm going to talk and trying to explain fraction mechanics for modeling crack propagation. Unless, if you show hands, you want me to skip this part. Thank you, Robert. Yeah, okay. So instead, let's talk about this. So we can't not stop it, but we get paid to delay it. So we have specifications, we have our pavement design guide, and we have best practices. So that's what I'm going to talk about. I'm going to talk about pavement design, mix design, construction. We have so many tools in order to delay cracking. So what's our pavement expectations? For refractive cracking, the rule of thumb is 1 inch per year. So if we place a 2-inch layer, we kind of know, and we're placing it over a crack pavement, we kind of know it may take a couple of years to start seeing the crack reflected. We know it's going to happen, but that's kind of a good estimation of how long it takes. And then the next one, the next bullet is reported ages at which surface cracking starts. So that's from surface to bottom. So France says 3 to 5 years, Japan 1 to 5, United Kingdom 10 years, Florida 5 to 10. Now, UT El Paso did a search, did this project 6679, and they sent a survey to all the districts. And the question was, what's the expected payment life of your mixes in your district? So we see a big range, like on the type C. Yeah, on the type C, well, we see the darkest part is here, around 5 to 12 years. And we have type D also in that range. But if we see an SMA, we expect those mixes, since it's higher quality, you use higher quality materials, you expect them to last longer. So what can cause early age cracking? Well, improper pavement design, excessive traffic load, that's a point that we're seeing pretty often now with the section, with the energy section. Sorry, I lost it. With the energy section, it's just so much traffic that our pavement we're seeing a lot of early age cracking. Then improper material selection and bad construction practices. Pavement design. So evaluate the existing pavement. So we need data before you design your pavement. You need to know what you have there. You need to know if you need a level up. You need to know what's your riding surface. And then you do your pavement design. You determine the thickness of your layers. You need to consider all the variables, traffic, temperature. And then you need to select the right mix for the right job. And now talking about refracting cracking, well, you need to select a mix with a high asphalt content. So do your homework. And I know you have seen maybe these graphs already in some, as you can tell, we recycle also graphs and everything in our branch. But this is real good data from the overlay test that we have in our branch. The overlay test tells you how the mix is susceptible to refracting, it's cracking resistant. So the higher the number is more, I'm sorry, I'm losing my thought. More crack resistant, right? Thank you, Caroline. So as you can see, the asphalt contents, you see more cycles when you go to higher asphalt content mixes. And then also, we know the finer the mix, also the better it does in the overlay test, because the finer the mix, you need higher asphalt content. So it all goes back to the asphalt content. And then Paul was talking about this, super pave use. We know if we move from dense graded mixes to super pave mixes, we're going to have higher asphalt contents too. So these are the districts that are starting to use super pave mixtures. This is another recycle graph, but I only highlighted these two mixes. This is a comparison from last year to this year. And we've seen an increase in use on super pave mixes because districts they know we need a little bit more asphalt content in our mixes. And then also the ton mixes. Ton mix is a fine mix that has more asphalt content too. Now, mix design. For mix design, we need to specify more durable aggregates, of course, when it's feasible. If you're going to use a Class A versus a Class B aggregate, and you have to take into account cost, durability, availability, road class, mix type, but also your absorption of your aggregate. If you're using, your aggregate is real absorptive, you're going to have less effective asphalt content. Specify softer binders or binders with a wider PG spread. Specify the high temperatures PG binder grade based on what you need for radiant resistant, and then specify the low temperature grade based on what you need for thermal cracking resistant. Recycle materials. This is hot. A lot of districts, they strongly believe that we can't create crack-resistant mixes when you start using recycle materials. But there's some best practices that we can use, and we really have to have real good control of your recycle materials. For example, control the moisture and variability of the stockpiles. For your RAS, control the moisture, grind real fine. By doing that, you're going to reduce your variability of your recycled material. And then wrap, you have to fractionate. We know if you fractionate, you're going to have a better mix. Recycled materials. These are the tools that we have in the specs for when you're using recycled materials to address early age cracking. For example, recycled materials are allowed in the specifications unless otherwise shown on the plan. So you still have the power of writing a general note saying, no, I'm not going to use recycled materials in my surface mix, but maybe on the other mix and my intermediate or my base mixes, I can still use my recycled materials. It's not recommended to use the maximum allowable percentages on surface mixtures. This is talking about recycled materials, recycled binder. We have a percentages there, but you don't have to go and use the maximum. Verify the asphalt content of the stockpiles during production. They're recycled materials. They're variable. We need to keep checking our asphalt content. Ensure the ratio of the recycled asphalt binder to total binder does not exceed the limit during design and production. This is again controlling, checking your stockpiles. So this is the dark side of recycled materials. You have start using more recycled materials, start using less virgin binder, and then stiff mixes, premature cracking, and then you have a shorter payment life. Now we have this tool using substitute binders. Use a softer binder when using recycled materials. We see in more districts using this, specifying -28 more, and they're seeing the result. For example, if I'm specifying a 76-22, I have the option of substituting with a 70-22, 64-22, 70 -28, and 64 -28. Now I have the option, and of course my maximum ratio is going to increase if I go to a softer binder. But you don't, just keep in mind that you don't have to use the maximum. So if I'm looking for a crack-resistant mix, I can use still my 64 -28 because I know I'm going to get a more flexible mix, but I can still use a low percentage of recycled material. Also, to get more durability, you can raise the target lab density or lower your end design. In item 341, which is our dense graded mixes, now you're allowed to increase the density up to 97.5, or your end design to decrease it to 35 gyrations. The VMA for this item was increased also 0.5% for production. So all these tools is again to try to put more binder in our mixes. Hamburg and tensile strength. We know that very low rub depths and high tensile strengths can indicate a relative stiff mix. For the Hamburg, we have this option for the engineer. If the Hamburg gets only 3 millimeters, the engineer may require the contractor to increase the target lab molded density. So you have from 0 to 12.5. Maybe you don't want to be you don't want to be too close to the 12.5, but also you don't want to be too close to the 0, 1, 2, 3 millimeters. And also some districts are even specifying in their general notes that a minimum rub depth for the Hamburg too. For construction, don't over stiffen or over oxidize the mix. Don't burn your mix. Don't produce your mix at real high temperatures. We know it's gonna make it stiff. And then you can use warmings and rejuvenators to reduce mix stiffness. During construction also, you have to include adequate surface preparations, ensure an adequate bond on the existing pavement. Again, what Jerry was talking, are you going to talk? You're going to seal coat it. And ensure that your mix is uniform and consistent. Robert also mentioned it real briefly. The equipment that we have new equipment that pay by our system for our thermal profiles. We have real good feedback about it. Contractors are seeing what's going on with the mix during paving, and we're all learning about production, how important is continuous production and all these things that we always thought it was a good thing, but now we're seeing it with all this data. GMF adjustments. It is some real important ignition oven correction factors. Sometimes we don't pay a lot of attention to them, but if we don't have correction factors, we don't really know our real asphalt content. So we may thinking we may be producing at this asphalt content, and in reality we're much lower because we didn't do our ignition correction factors. Also, when they doing GMF adjustments, let's check they're meeting their maximum allowable amount of RAB and recycled materials, and then they're also meeting the recycled binder to total binder. And then you can also always run your ADT and Hamburg to see where you are. Aging ratio, you're suspecting that they're burning your mix. You can always run your aging ratio. We'll run DSR and compare it with the original DSR. Another practice is do proper joint construction. So going back to the black side of recycled materials, Robert and Andy was talking about sustainable pavements, and we know we can create good crack-resistant material mixes with recycled materials, and we have the tools. If you want to use recycled materials, you need to select the right mix time first for your pavement. Then you have this tool, warm mix asphalt, and then you can use softer binder, and then that will give you an adequate asphalt content for your mix, and then you create a crack-resistant mix, and then you meet your expected pavement life. In summary, you need to keep in mind that there's a lot of tools during pavement design, materials, and construction. You need to have your correct pavement design, the right mix selection. You have to, sometimes it's hard, but you need to have your right or close enough traffic data. And then for materials, you need quality and uniformity in your materials. A mix design, you can use your performance test. Construction, use your QC/QA testing, and just keep checking those changes in your GMFs.